If I asked you to give me an example of two lines, the gradients of two lines where that we know they're perpendicular, what would you say? What would their gradients potentially be? Jack?
3 and -1/3.
So if the L1, if the first line had a gradient of 3, then line 2 would have a gradient of -1/3. Remember that? If line 1 had a gradient of 3 divided by 2, then line 2 would have a gradient of -2/3. Good. Okay. All right. You all remember that? So if we're having a look then at question 4 on page 128. Question 4 on page 100. It says, which of the following lines are parallel and which are perpendicular? So, we don't know. We could use Desmos, because by putting it in we could see whether they're parallel or not. But now we're not going for the graphical approach, we're going for the algebraic approach. So we're going to see whether they're parallel based on their equations, not the line itself. All right? So if we've got, for instance, A, the equation is, computer, x minus 7y equals 10. So if we need a line that is parallel or perpendicular to that one, what would the gradient be? So if parallel to this, m will equal what? Or if perpendicular to this, m will equal what? Any ideas? Cameron?
Would the perpendiculars be x take away x?
Well, let me say that a gradient does not have, well, at the moment for you with a straight line, a gradient does not have an x in it. It's a number. So, what's the problem? Why are you all struggling? What's the gradient of the first of this? What is it? It's not, no. It's not 7. It won't have an x in. Why is it 3? Just 10 minus something there. Something like that. No. It's not -7. It's what? It can't have an x in it. Those, you know. The gradient. What does gradient mean again? Rate of change. Therefore, it's got to be a number. Yeah. 7 would be 7% per minute. You know, we're talking phone charges again. Can't be 7x per minute unless it's changing, which you'll do in M5. Not today. But we've got a constant change, a constant rate of change, which means the gradient is a single number. What do we need to do? Well, what form of equation have I got here? What's it called? This is standard form, right? Can I see gradient from standard form? No. What do I need to put it in? Charlie? I need to go from standard form. To be able to answer these questions, I need to do no idea. Des? I could do point slope. The trouble with point slope is I don't know a point or the slope. So there's a final one, which gradient intercept.
Isn't
Okay.
gradient and slope the same thing?
Yes.
So why did they say that separately? Because like in the book it says point slope, but then it says gradient intercept. Why don't they just say point slope and slope intercept?
I just think maybe it's just because that's what people generally say. I don't know. It's a good question. I don't know why they chose to do that. To be honest, when I grew up doing maths, I didn't ever call it slope. It was always gradient to me. So,
So is point slope and gradient from the exact same thing?
no.
They're different things.
No, so do you remember when we could create point slope? So if I know a point like 3, 6, and I know the slope is -2, for instance, it's really easy to write point slope form. Be y minus 6 equals -2 times x minus 3. So that's point slope form. So I can write it. Now what if I have it in that form, what's the gradient? -2. But I wouldn't need to use it because I'd have it already. All right. Now the situation I've got here is I don't have a point. And therefore I don't have the gradient or the slope. All right. That is one option though, isn't it? Could I use the equation to find 2 points to work out the gradient? Definitely can, and I think the fact that there was a little confusion there means we need to do it. All right, we should do that because it's. I've got problems with my M4s at the moment, not really understanding about what a formula, what the equation's all about. So we'll have a look at that afterwards. But the easiest way to do it is to rearrange that into a different form, and we could try and rearrange it into this form, but it's not the easiest one. We can actually go straight from standard form to gradient and intercept form. All right, and how do we do that? Well, gradient intercept form looks like what? Got it? Y equals mx plus c. Yeah, that's the form we want to be in. So we need to get from x subtract 7y equals 10 to y equals mx. And then I know what the gradient will be. It will be the m. All right? So once it's in that form, I know the gradient easily. All right, so first step, let's rearrange x minus 7y equals 10. Let's rewrite that in the form of y equals mx plus c. Go on, Charlie, you got your hand up again? What would you want to do first? Minus 7y. Pardon? What about it? What do you want to do with the 7y? No, I mean, fine, you can. But what do you want to do? Do you want to minus 7y? No? Add 7y. Do you want to add 7y? Well, if we add 7y to that side, we eliminate it from there, right? And then we have 10 plus 7y on the other side. So we x equals 10 plus 7y. Okay? Good start. Still not what I need, but it's a good start. What can I do now? Go on. Subtract 10. Good. Like it. Let's subtract 10 from both sides. And I get x subtract 10 equals 7y. Then we can divide by 7. Okay. If I divide that by 7, I get 1y equals x minus 10 divided by 7. What's the gradient? This is where we might want to, because it's fine. That's correct, by the way, but it's still not quite what we're used to seeing. So what we need to be able to interpret that. So I'm going to ask you, this here we divided by 7, yeah? That's what we did, yeah? Divide by 7. Is there another way of dividing by 7 without dividing? By multiplying.
Oh,
So what can we do? Instead of divide by 7, we can multiply by 1/7. Same thing, right? So instead of doing this now, we'd actually go a different route over here and say we could do 7y times 1/7 equals 1/7 of x minus 10. Same thing as divide by 7, yeah? Happy with that? The lack of noise is either really good or really worrying. Are you happy with that?
Yes,
Yeah.
Mr. Colt.
Thank you, Jillian. So what does 7y times a 7th do? What 7 times a 7th is? 1. So that's why I end up with 1y. And then I've got 1/7 of all the other side. That's why I put brackets. And when I expand the brackets, what do I get? 1/7 of x minus 1/7 of 10. So I'm just going to do that as 10 divided by 7. Can you see how this form could have been written like that anyway? I could have just done x divided by 7 minus 10 divided by 7. But then I still need to interpret the gradient of that. So I need to understand that dividing by 7 is the same thing as timesing by a 7. Yeah, so we have to understand that, otherwise we're not going to get this right. Right, so that would still be 1/7 of x minus 2. So we end up at the same point, either way. All right, so what is the gradient now then? 1/7. Okay. Now, I can go back up to here. If parallel, what will m be? 1/7. Okay? 1/7. If perpendicular to this, it'll be -7. Good. All right. So now, what we have to do is go through the other equations and find out any that have a gradient of either a 7th or -7th. Yeah? So looking at question 4, we've worked out A has a gradient of a 7th. Does B have a gradient of whatever? Can you see what we have to do now? So probably all of those you are going to have to rearrange into gradient intercept form, and then you can answer which ones are parallel and which ones are perpendicular. Is that all right? So, would you like me to do one more with you? Because we talked a lot there. So, for instance, let's just write that down. So, A, we've got m is 1/7. The gradient is a 7th, right? I'll come back to this page when I've done some of the others. So B then, that is 2x minus y equals 8. Now this one's going to be a nice easy one. How can I rearrange that one into gradient intercept form? First step, add y to both sides. If I add y to both sides, I get 2x equals 8 plus y. Okay, then I subtract 8 and get 2x subtract 8 equals y. What's the gradient of B? 2. Don't worry, I will come back to it. For B, the gradient is 2. Now I've got a question for you. Have a think while you're doing the others. For instance, did I need to rearrange that one to know what the gradient was? It was, even though it wasn't in gradient intercept form, rearranging it didn't change the gradient. The gradient was still the 2 before the x. It wasn't in the other one though, was it? So, while you are doing all of these, this is a criterion B moment. Right? Those people that are good at spotting patterns, this will make your life quicker and easier. So while you are working out all the others, maybe you can spot a way of going, well, I don't need to rearrange all those ones to know what the gradient is, even though they're not in gradient intercept. And I look at that one and I go, I do know I need to rearrange that one. So that would be a good way, thing for you to think about. When do I have to rearrange to know what M is, and when do I not need to? All right. So I'll let you carry on. Question 4, all of those you're going to need to find what the gradient are. Some of them are going to be not need to rearrange at all. A couple you might need to rearrange. Is that all right? And then you need to pair them off, don't you? Which ones are parallel, which ones are perpendicular? Well, then you'll look, well, we already said, Charlie. So with this first one, here, look. For it to be parallel, we have to have a gradient the same, 1/7, if it's perpendicular. So once you've worked out all the gradients for all of them, you can then pair them off. Which ones are parallel, which ones are perpendicular, and so on. Because you'll know all their gradients. And how do you know if 2 lines are parallel? The gradient will be the same. How do you know if they're perpendicular? The negative reciprocal thing, yeah? So once you've got all the gradients worked out, it's a simple matter of, well, which ones have the same number and which ones have the negative reciprocal.
Wait, but what are you comparing?
All of them. Question 4 is which ones are parallel and which ones are perpendicular. Yeah? That's what you're answering.